Okay, so we've looked at some of the connection coefficients for spherically, symmetric, and static space-time. Some of them were non-zero, some of them were zero. Let's just go through the ones that are known not to be zero. So gamma 1, 1, 1 is equal to 1/2 G1D. Right, we're summing on D. GD1 x1 plus dg1d in x1. There are only ones here, minus dg11 respect to xd. This will reduce to just one term. So these will add and one will cancel. They're all the same, which gives us 1/2 G11 dg11 and x1. And just notice that the connections have derivatives of the metric, and they go into the curvature tensor, or the Riemann, actually the Ricci tensor. Either way, there are other derivatives of this, so there are higher order derivatives of the metric. That's the equation. Those are the kinds of equations we're going to get. Let's see, gamma 1, 2, 2. This looks like 1/2. Well, we get G11, dg12 in x2 plus dg21 in x2 minus dg22 in x1, and that gives us minus 1/2 G11 x2 is that's theta derivative in theta. Well, G12 doesn't exist, so we have dg22 in x1, derivative with respect to r. We'll evaluate that, but it survives. So well, we can sort of evaluate it right now. Let's see, that's G22 is r squared, so that just gives us 2r. We take the derivative with respect to r, so we have a minus r, and that's the inverse of G11, so it looks like that. Gamma 1, 3, 3 looks like 1/2 G1D. Let's just go through this. We know that we're going to get only the D equals 1. So that's 1. And here we have the G13, that's 0, 3. The flipped of this, that's also 0. Minus dg33 with respect to r, and so that becomes minus 1/2 G11 33 in r, which is well, this G33 is r squared sine squared theta, so we get a minus r sine squared theta with respect to, divided by G11. I think I did that right. Let's see, gamma 1, 3, 3. So we have gamma 2, 1, 2. And so we have a 1/2 G22, and well, we just have the G22 with respect to x1. Let's see, gamma 2, 3, 3. We have G22, so we have minus a half G22 dG33 and x2. That's what we should get there. And we can evaluate that further. That's with respect to theta. So we have r squared sine squared theta. So we have 2 r squared sine theta cosine theta. And so we have so that cancels with them. Well, we still have the minus, but we can cancel the 2. The G22 upper, that is, well, G22 lower is r squared, so that's 1 over r squared. So we actually get rid of the r squared. So we get minus sine theta cosine theta for that one. And gamma 313, we have G33. So we have a half G33 dG33 with respect to x1. That's the only one that matters. G33 is, again, r squared sine squared theta. With respect to r, it's 2r sine squared theta. But then we're canceling the sine squared theta from this one. So we have 1 over r squared. So we end up, the 2 cancels here, so we just have 1 over r for that. And then the last one that we know not to be 0 is gamma 323, which is 1/2 G33 dG33 with respect to x2. And so with respect to theta, so that's, so the r squares will go away with this. We'll get a factor of 2, that'll go away. We'll just have the cotangent of theta.